This is the development of an AI-enhanced autonomous drone for pollution monitoring and emission predicting. And I'm Karthik, and I'm presenting with Sahil, Avi, and Shivesh today.
What is the problem? The problem is that pollution is a global problem that needs close monitoring in order to be fixed. Currently, there are policies to curtail climate change. However, there is still more that can be done. Our autonomous drone aims to monitor pollution in real time to predict trends and give suggestions on how to curtail pollution by giving areas the pollution is coming from and what it is, and etc.
There are already some existing solutions to detect pollution. One of the solutions are fixed monitoring stations that can detect particulate matter such as carbon dioxide, nitrogen dioxide, or methane. These stations only collect data from specific locations and are expensive to maintain. An autonomous drone is a more effective solution because it is flexible and mobile. A second solution are satellites that are equipped with sensors that can detect matter and various types of light, such as visible and infrared light. The resolution from satellite imagery will not be as good as autonomous drones because they may be affected by weather conditions. Autonomous drones can operate in different weather conditions and are lower to the ground, which make them a better solution. A third solution is crowdsourcing, which involves large groups of people collecting and analyzing data related to pollution. Crowdsourcing is not a practical solution because opinions may differ and standards are difficult to establish. Autonomous drones can do the work in a time-efficient manner and while providing the most accurate data from their findings. Last but not least, the final solution are plant bioindicators that show visible signs of damage and indirect clues of air pollution in nearby areas. Plant bioindicators are not responsive to short-term changes. With the use of autonomous drones, short and long-term patterns can be collected for analysis.
So what are we going to do about this? We plan on using machine learning and sensors implemented in a drone to record atmospheric conditions. Specifically, we'll be tracking nitrogen dioxide, carbon dioxide, and methane, which all contribute to the greenhouse effect. When launched, our drone will track locations and adjust its position to areas of higher concentration. While doing so, we will then identify major sources of each molecule based on the collected data. Finally, we'll add clean energy sources in the areas to combat greenhouse gas emissions.
All right, so this is our materials list. So we're gonna use a quadcopter frame for the drone. We have motors, then we have an electronic speed controller, flight control boards, propellers, radio transmitter, battery, electronics, and power distribution cables. And then we're gonna use AI with our machine learning, and we're gonna collect data sets, and we get pollution data. We get our pollution data library and classification model. And then we have our air quality sensors, which is a PM 2.5 air quality sensor with volatile organic compounds to measure pollutants like nitrogen dioxide, carbon monoxide, and methane. And then we have sensors for our autonomous drone to work, like our camera sensor, LiDAR, radar, barometer, inertial measurement system, and the global navigation system. Our LiDAR is to detect things that are around 3 meters away, so it doesn't run into anything. And we also have a radar that's for a closer distance.
So for the first step, we're going to be collecting data, and our data will be in numerical form that's related to air quality levels and concentrations of each of the molecules. We'll then have we'll then have designated training data to train a machine learning model, how to calculate the concentrations of these molecules. And then through different accuracy checking techniques such as confusion matrices and cross-validation, we'll use separate testing data to test for the accuracy. For the hardware, we'll construct a drone with sensors to measure the density of each molecule. Additionally, cameras, radars, and radios will be placed for the communication and location of our drone. Putting it all together, the trained model will be built into the hardware to begin collecting and assessing data. We'll also have a notification system using radio transmitters to communicate pollution levels to drone operators. Upon data analysis, we will derive technological solutions that address the concerns shown by the data to work towards a safer and cleaner environment.
Hold on 1 second. I have a question. This is data collected by the sensors, you said? You're gonna put sensors?
Yes.
Data collected by sensors?
Like, we were gonna like have we're gonna plan to make an algorithm that we use the sensors and they kind of like record like the concentrations and then translate it into numerical data.
So this is real-time data?
Yes, that's what we plan to do.
Okay.
Sensors and how our autonomous drone works. An autonomous drone works by using sensors to gather data about its surroundings, a flight control system to process data and maintain stability, and a pre-programmed instruction to navigate and perform tasks by itself without human intervention. Sensors that I want to talk about. We have the LiDAR sensor, which emits laser pulses and measure the time it takes for the light to bounce back after hitting an object. We have a global navigation satellite system, which uses satellites to broadcast signals containing its precise location and time. We have the inertial measurement unit, which uses gyroscopes to measure the rotational motion and linear motion. We have a camera sensor that captures images or videos to navigate, avoid obstacles, and detect and track objects. We have a radar that detects different movement speeds inside the drone. And then we have a barometer that helps the drone maintain stable flight by adjusting altitude based on changes in air pressure.
So ultimately, what do we want to achieve with this drone? So our ultimate aim is to use the drone to determine the areas with the most concentrations of greenhouse gases, including nitrogen oxides, carbon dioxide, and methane. And using our drone, which detects the areas that need help in monitoring pollution levels, we can use its real-time data. That's the whole point, that it's having real-time data and its predictions to keep track of the areas that need help with monitoring pollution levels. The drone will give readings of the greenhouse gas concentrations in real time using the machine learning algorithm trained on numerical data sets from different areas, readings in greenhouse gas concentrations. And since the predictions and readings are constant and in real time, this method will be far more efficient compared to other methods such as plant bioindicators that we mentioned before. And it can help be given to areas given help that needs to monitor pollution levels as quick as possible, having a long-term benefit overall. And another thing I just wanted to say is that our project is still a work in progress. Our potential outcome is to use this drone to measure the pollution levels and help the areas in need, but it's still a work in progress. So we still aim to find the correct machine learning algorithm and classification model to detect the concentrations and readings in real time. So these are the references we use to see the other potential solutions for air pollution problems and how we use these to formulate our own method using autonomous vehicles to detect air pollution. And finally, we would like to thank ASDRP and Dr. McMahon for their guidance and their resources. Does anyone have any questions?